Hi, good afternoon. Thank you for joining us for today's Waste Reduction Network webinar. My name is Bruce Long, and I'll be serving as the moderator. Before we dive in, there are a few housekeeping points I would like to cover. Please note that today's webinar will be recorded and archived on the Better Building Solutions Center. In a few days or weeks, you'll receive a link to today's recording and slides following the webinar. Next, I just want to make sure everyone's aware that you'll be in listen-only mode as attendees, so your microphones are muted. If you experience any audio or visual issues throughout the webinar, please send a message in the Q&A box located at the bottom of your Zoom panel, and one of our staffs will get to it real quick. Next slide, please. So once again, this is me, Robert Bruce Long. I'm your moderator, and we're looking forward to having a really good webinar today. Next slide, please. Just to let you know, we'll be using Slido as the interactive platform for question and answer and polling today. If you can please go to www.slido.com on your mobile device or computer, on your browser. Today's event code is hashtag WRN, and you don't have to hit the hashtag, just the letters WRN. Also, if you would like to ask our panelists any questions, please submit them at any time throughout the presentation, and then we'll be answering your questions near the end of the webinar. We can also select the thumbs up icon for questions that you like, and that will cause them to become more popular, and they'll move further up to the top of the queue and hopefully have a better chance of getting answered. Next slide, please. I just wanted to give you a quick idea of all the folks who have joined all the partners that have joined the Waste Reduction Network in the Better Plants and Better Buildings program. We have two new partners as of this webinar, Flexco on the industrial side and Vornado Realty Trust on the commercial building side. And this network is open and available to all partners in Better Buildings, Better Plants, Better Climate Challenge. If you're interested in waste reduction and you have a goal, feel free to come and join us. Next slide, please. Right here, just want to give you a quick idea of the team behind the Waste Reduction Network. In addition to myself, there's Marta Jimila from BTO, who's very good and is helping us work on ideas. We also have Jasmine Schmidt from ICF in support, Julia Cox from Retech Advisors, as well as a subject matter expert at the Oak Ridge National Lab named Subodh Chowdhury. If you ever read our newsletters, he's the one who's behind the Tip of the Month articles. So next slide, please. Wanted to give you a quick idea. If you're ever on the Solutions Center, this is where we keep all the information related to the Waste Reduction Network. So all the news that's going on with it, all the new solutions, partners, that kind of thing. So feel free to visit our page and if possible, learn from some of the new solutions out there. Next slide, please. If you are interested in joining the Waste Reduction Network, it's pretty easy. It's basically a bring your own goal type of thing. So if you have a goal or you just want to set up a goal, you can bring that in. For the industrial side, we have a variety of options that people can choose, and your TAM will be able to help you during that process, as well as giving you tips from the network and stuff like that. As with all the other data that we collect, whether you're doing energy or if you're in the water savings network, our data deadline is May the 5th of this year. So next slide, please. So today's webinar, we're going to talk about molecular plastics recycling within the context of circularity. I don't think I need to tell people that circularity and sustainability and recycling of materials is a big deal. We know that at DOE, the recycling of plastics has actually been a pretty big deal. We have two consortia just related to sustainability and plastics recycling. So the first one here we have is the Bottle Network, or the Bottle Consortium, as well as the Remade Consortium that focuses on sustainable manufacturing. We also have had some guest speakers when we had a pilot of the Waste Reduction Network. We had some guest speakers during a plastics recycling working group, some speakers from the American Chemistry Council to talk about some of the advanced manufacturing techniques. And then Remade also gave us a speaker. We also had some internal presentations from partners, and that's where we learned about things like the Gabby tool, which is widely used as a kind of a life cycle assessment estimator, depending on what product mix you're making and how easy it is to recycle some of the products that you're making. In addition, we've worked with the Oak Ridge National Lab to develop a white paper in which we had some contributions from some of our biggest partners, the Wapaka Foundry and Volvo Group. So this is definitely a topic that we're staying on top of and want to help bring to your attention. Next slide, please. So today we'll have Christopher Layton, also known as Chris Layton from Eastman Company. And the nice thing with Eastman is that this is a company that's been doing a lot of right things. Going back to the 1930s, they installed combined heat and power systems back then. They've also been a longstanding partner, sustained partner with the Energy Star for Industry program. They've been in Better Plants Challenge and now also in the Better Climate Challenge. So we're definitely interested in hearing from Chris. And I think what you'll see is that this new methanolysis plant and process is a good example of what a forward-looking company can accomplish. Just to intro Chris a little bit more, Chris is the Eastman's Director of Circular Policy Strategy. He helps the company build sustainable solutions to the global waste crisis and leveraging Eastman's molecular recycling technologies. He works with other partners throughout the value system to help shape a constructive policy landscape that will foster a circular economy, particularly with plastics recycling. He has more than 15 years of related business experience and a passion for creating a more sustainable future. And so he's going to help Eastman make the most of the world's resources. And with that, I'll hand it over to Chris.
Thank you, Bruce. And so as Bruce said, I lead Eastman's circular policy strategy and communications team. And thank Bruce, Marta, the whole DOE team for giving us this opportunity. As he said, Eastman has partnered with the DOE since 2010. We're a Better Plants and Better Climate Challenge partners. So really excited today to share a little bit about who we are and what we're doing to try to create a circular economy. Next slide, please. So quickly by way of background and then share a little bit of what I'd like to accomplish today. So I've been with Eastman for about 25 years, started in environmental, but moved into technology and spent most of my time in commercial roles. So in my current role as leader of our circular policy strategy team, my team and I are responsible for engaging with our brand partners, NGOs, standards bodies, and more or less anyone that will listen to us to educate folks on what these molecular recycling technologies are and are not. And then most importantly, to help build collaborations and partnerships to drive policy, drive innovations and investment, help improve the infrastructure to increase recycling and create circularity. So hopefully today, I'd like to do two things really. First, make sure or share with you a little bit of what molecular recycling is. And for clarity, I'll use molecular recycling. It's a term we use at Eastman because we think it represents what these technologies do. But it is sort of an umbrella term. And so similar terms that you'll hear will be chemical recycling, advanced recycling, enhanced. All are sort of umbrella terms for a variety of different technologies. I'll talk about molecular recycling, and then I'll highlight the two specific technologies we practice. The second objective is beyond just that basic understanding, would really like to share with you some of the partnerships that we've done that are hopefully increasing recycling and or driving circularity for various materials. So, next slide, please. Quickly, before we begin, just a little introduction of who we are. So Eastman is about a $9 billion specialty materials company. This year will be 104 years old. We're headquartered in Kingsport, Tennessee, but we have a team of more than 14,000 people located at manufacturing plants, research centers, and sales offices throughout the globe. While we may not be a household name, there's a good chance you use a product made with one of our materials, as we sell to customers in over 100 countries across a wide variety of applications. And when you think of plastics, think of applications like houseware, small appliance, medical, electronics, auto, and of course, food, beverage, personal care, cosmetics, packaging. Next slide. Our mission as a company is to improve the quality of life in a material way. And so as we thought about that mission, we thought about the next 100 years of our company, we quickly realized that the as a society, we're facing three challenges that could potentially impact that quality of life. First, how do you sustainably care for 10 billion people, or a world fast approaching 10 billion people? Secondly, most people would admit and agree that we have a plastic pollution problem. Lastly, climate is changing. With that comes a whole host of consequences. So we have chosen to put our money where our values are and have been investing in these two molecular recycling technologies with the goal of bringing those technologies to bear, those innovations to bear on trying to solve this triple challenge. Next slide. So I talked about the plastic pollution challenge, and this slide sort of quantifies that challenge. So if you look at it as an industry, we generate more than 460 million metric tons of virgin plastic every year. When you subtract out what goes into durable goods, you still end up with more than 350 million tons of plastic that has reached to the end of its life. And the unfortunate reality is illustrated on this slide is that, only a small percentage, less than 10%, actually gets recycled. You see, close to 80% ending up in a landfill or incinerated, 20% leaked into the environment. Obviously, that's not sustainable. Obviously, that's part of why we have a problem. And so when you think of these molecular recycling technologies and what we're trying to do, we're trying to bring them to bear on this system, complement that existing mechanical recycling system to be able to tap into those streams that today are otherwise going to landfill, incinerated, or in worst case, ending up in the environment. Next slide, please. So before we go much further, I want to make sure I'm throwing some of these terms, molecular recycling, mechanical recycling, around and assuming everyone knows it. But what I'd like to do is maybe the simplest way to explain molecular recycling is to contrast it versus mechanical recycling, what you and I probably would think of when we think of recycling. So in mechanical recycling, simply think of starting with a relatively homogeneous material. Clear water and soda bottle, natural milk jugs are the best examples. Those materials get put in the curbside bin, collected, sorted out, chopped up, and then generally remelted with the addition of some virgin plastic to create a new article. Oftentimes going back to that original bottle, other containers or other materials. Very simple, very efficient process that allows us to recycle a lot of materials. But it always requires that input of new virgin material. There's limitations on what you can do. So it alone will not create circularity. It needs other technologies. And that's where molecular recycling, we believe, can be a key complement to that. In molecular recycling, we have the ability to handle a much wider variety of feedstocks. So don't think about that clear water and soda bottle. Think instead maybe the colored shampoo bottle in your bathroom. Think about the clamshell packaging that you purchase meats or vegetables in. Think about textiles like carpet, things like that. Materials today that get into the recycling system but probably either drop out or don't get recycled in any meaningful way. So in molecular recycling, you take those materials and either through thermal or chemical means, we break them down into the basic building blocks. That allows us to purify those building blocks. And then we and other practitioners feed it into our existing processes where we can build a whole host of products without any sacrifice in safety, quality, and performance, because we've gone back to the basic building block, and potentially do that, an infinite number of times, because you're always going back to the building block. So the two technologies very much complement one another. Next slide. As we've been on our journey, when we first started trying to launch these technologies in 2019 and kind of communicate what we were doing as a company of chemical engineers and chemists, we love to talk about the technologies. And while you'll get policymakers, NGOs, customers that will entertain that and will be curious, they're generally focused on the benefits. And so we've pivoted a little bit to try to communicate what we see as the benefits or some principles to guide how we're making investments in these technologies. I won't go through all of them, but I'll highlight a couple that are pretty important as it relates to these specific technologies. First, we're only investing in these technologies where they are true sort of material to material, meaning we're taking a waste plastic that was otherwise going to a landfill or an incinerator, recycling it into a new material. We're not doing waste to fuel or other things like that with this. Secondly, we're only investing in these technologies when we can get to those new finished products with a lower greenhouse gas emissions than we otherwise would be able to achieve using fossil feeds. Third, these technologies need to be thought of as complements to the existing mechanical recycling technologies. They are used in addition to mechanical recycling, in addition to reuse and refill. They are not the solution that gets us to circularity. It's going to be multiple solutions and innovations. And then lastly, it's this idea of transparency. While the base technologies that we're using are technologies that we've practiced for many years, using them to recycle waste plastics at this volume is relatively new. And so we felt it was very important to be transparent. We achieve that transparency through a third-party certification for the products that we sell, international sustainability and carbon certification. And what that does is allows us to give comfort through the value chain. So when our brand partner ultimately makes a claim related to recycled content or other environmental benefit, they know they have a clear chain of custody through our process. And at the start of that process, an appropriate amount of waste plastic has been recycled. Next slide, please. So as I said, Eastman has been practicing or operating two molecular recycling technologies since the fourth quarter of 2019, what we call carbon renewal and polyester renewal technologies. So in carbon renewal technology is a form of gasification. And as you can see, it's a fairly robust in terms of the types of plastics that we can feed. We found some things that we don't like, PVC or other halogens. Nylon can be a little problematic, but otherwise fairly robust technology. And so examples of things that we're feeding today into this unit would be carpet fiber, some amount of textiles, cellulosic polymers, some polyolefins. And in the way carbon renewal technology works is you take those hard to recycle materials and high temperature, low oxygen through gasification, we're breaking those polymers back down into the basic building blocks of carbon, hydrogen, and oxygen in the form of a syngas. We can purify that syngas such that it's indistinguishable from the same syngas today we produce on fossil feeds, which for us would be coal. We then feed that syngas into our existing manufacturing processes, and then we produce a whole host of products, everything from a fiber, a cellulosic fiber we call Naya that goes into Patagonia and H&M apparel. We produce a cellulosic polymer that goes into the eyeglass frames for Warby Parker. And we even produce a biodegradable compostable polymer called Aventa from that. Basically, because we've gone back to that basic building block, we're able to then, everything else after that is very similar. Polyester renewal technology, as the name implies, is focused on polyester. And again, don't think of the clear water and soda bottles. Those are best handled via mechanically recycled. Think of hard to recycle polyesters, shampoo bottles, dairy products, over-the-counter medicines, thermoform clamshell packaging, textiles, carpet, etc. Through either a glycolysis or a methanolysis process, in short, ethylene glycol or methanol, we're able to use those materials, catalysts that then simply unzips that polymer, takes that PET, breaks it down to the basic building block, in our case, DMT, dimethyl terephthalate, EG, ethylene glycol, the building blocks for polyesters. You get back to that small molecule, it allows us to purify that molecule such it's indistinguishable from the same molecule we produce today on fossil feeds. And then we feed it into our existing polymer lines, and we can produce a whole portfolio of products with really no compromise in safety, quality, and performance versus what we do on fossil feeds today. So all that said, it's probably pretty obvious of how we're diverting materials that would otherwise end up in a landfill or incinerator, or maybe downcycled at best. What's less obvious is that when you start with waste plastics, you've eliminated many steps or several steps in the traditional fossil-based production process, right? We're not having to extract oil or natural gas. We're not having to refine that into naphtha. We're not having to crack the naphtha into ethylene and propylene. You've eliminated all those steps. So as a result, you can get to that syngas, you can get to that DMT, and ultimately those finished products with significantly lower greenhouse gas emissions than you could otherwise. In the case of carbon renewal, that can be anywhere from 20 to 50% lower greenhouse gas emissions, depending on the type of plastic we're feeding, how far it's coming from the source of generation to our plant, and what, if any, pre-processing we need to do in order to get into our reactors. For carbon renewal, that range is about 20 to 30%. So again, both pretty significant reductions, and it kind of highlights how these technologies can be leveraged to not only drive circularity, but in so doing, you're also helping address the climate issue. And of course, you're able to get recycled content into applications that help that, caring for a society fast approaching 10 billion people. Next slide. So as Bruce kind of highlighted, today we are upping those two technologies, and between the two, we can roughly are recycling about up to maybe 50 million pounds a year. We're in the process of starting up a new methanolysis, a new polyester renewal technology that, when we get it lined up and running, will allow us to recycle up to about 250 million pounds of waste plastic, so almost a five-fold increase. And it will be one of the largest of its type, if not the largest of its type in the world. That's starting up here in Kingsport. And earlier last year, we announced two other projects, or our intention to invest in two other projects, one in the Normandy in France, or Normandy region of France, and a second one in the US. Between those two projects, that allows us to achieve our circularity goals, which would ultimately be recycling more than 500 million pounds of waste plastic by 2030. Next slide. So I've talked a couple times about hard to waste, hard to recycle polyesters and feedstocks. This picture is worth 1,000 words. So this is an example of the types of materials that we are feeding into our process to recycle. And so I mentioned the colored and opaque shampoo bottles and milk drinks, the clamshell packaging. We also take the waste streams from today's existing mechanical recyclers, right? As they purge their systems, they generate waste streams. We're able to take those materials that are polyester rich and be able to recycle them. Sometimes those materials get downcycled, and so strapping is a great use of after so many times of going back to a bottle, there's no choice but to sort of downcycle it into something like strapping. Well, that strapping is PET rich, we can use. Same thing with carpet fiber that we do. So this is an example of when we say hard to recycle, this is the stuff we're doing. You notice if there's a clear bottle in there, it hitched a ride. It's not what we're going after to recycle. Next slide. As I said, today we can do up to about 50 million pounds with the methanolysis unit that's starting. That number will go up to 250 million pounds. People are always like, hey, how much is that? Well, it's a lot. So we're about 2 hours northeast of the University of Tennessee and at Oak Ridge Lab. Neyland Stadium is home to the Volunteers and one of the largest stadiums in the country. 250 million pounds would fill that stadium 2.5 times at least. So it's a lot of waste plastic. It by no means solves the problem on its own, right? That's just a small bite out of the larger problem, but it's a meaningful start and one that we're pretty excited to get going. Next slide. Talked a little bit about the input. Well, let's now talk about the output. As I said, one of the advantages, one of the way this technology complements mechanical is by going back to that building block, you can produce a monomer and then ultimately the finished polymers where there's no change in the safety, quality, or performance of that versus what you produce on fossil feeds. So it allows us to get recycled content into applications where that would previously have been limited. So you can see this is a list of companies that have been buying Renew products, as we call them, since we started up in 2019. And you can see there's a wide diversity of applications, power tools, shampoo bottles, clothing, some cosmetics brands, a lot of eyewear. So very diverse set of applications enabled by this technology. And all these companies are leaders in their sort of respective space, and they recognize the value of using more sustainable materials. It allows them to meet their sustainability goals, as well as differentiate themselves and grow their businesses. One of the key parts as we think about collaborating across the value chain is having good partners to help pull that demand along. Next slide. So a lot of information, pretty fast, but hopefully you have a better perspective of what molecular recycling is. What I'd like to do with the next few minutes is share with you some examples of how we're leveraging these technologies, how we're collaborating differently with folks across our value chain to increase recycling, to drive circularity. And my purpose in sharing these is not to show off of what we're doing, nor is it to suggest we've got this all figured out. Far from it. What I really want to do is hope you maybe trigger some ideas of how to think differently about collaborating, how to think differently about driving system change. We've been at this for 3 years. Some things have worked well, some things have not. We've made good choices, we've made bad choices, but what we have learned is to very quickly learn and be able to adapt, because it turns out solving the world's waste, plastic, and climate, and caring for society challenges is a little harder than we would have expected going into it. So it's absolutely critical to kind of have a little bit of courage to take a risk, but then know when you're going to fail and review and adjust quickly. So as I talk about these different examples, I won't go through any of them in great depth, but I will kind of highlight what we're doing in all of them and how we're sort of changing the system as a result. But if you think about molecular recycling as complement to mechanical, think of it in 3 ways, and you'll see this kind of reflected as we go through the examples. First, we're complementing mechanical by being able to recycle the waste streams that mechanical generates, and then creating that virgin quality material that's needed to replenish that system. Secondly, and you'll see this come across, we're able to recycle materials that today don't get recycled in any meaningful way through that system. And then many times will go directly to a landfill and incinerator at best. Lastly, and I highlighted this, is we're able to get recycled content now into applications where today that would have been prohibitive from a quality, a fitness for use, food contact requirement. So the 2 technologies sort of work hand in hand to drive circularity. And hopefully that comes across in the examples. And again, hopefully triggers some ideas for you all. Next slide. So without a doubt, the best way to reduce virgin plastic usage and create circularity is to convert to more reusable, refillable applications. So we make a product called Triton that has great durability, great chemical resistance. It can withstand hundreds of wash cycles. So as a result, it finds itself in a lot of these reuse, refillable type applications. In Europe, as they are working towards their green plan or circular economy action plan, they're requiring restaurants, other facilities to convert a portion of their packaging to reusable, refillable models. And so we've been collaborating with McDonald's and various partners in their value chain to be able to transition to more reusable food serviceware in their stores throughout France, Germany, and elsewhere. It allows us to get Triton based on recycled content into those applications. And we're just now beginning to figure out how do we get those materials back, be able to recycle them, leveraging our technologies, to then in turn return it back, essentially create circularity for this reusable, refillable tableware. A great example of how we're doing, and a great example of where we learn, right? In store, this works really well. We saw as many of these things walk out of the store as stayed in the store. For takeout, different stories. So just another example of how some things worked well, some things haven't. Multiple players in the value chain to accomplish that, but kind of a real interesting story around reusable, refillable. Next slide. So another example of kind of getting new materials into the system or doing a better job with materials that do get into the recycling system today. So I don't have actual data, but sort of anecdotally, as consumers, we do a pretty good job of recycling stuff from our kitchen. We do a less good job of stuff in our bathroom. And then certainly when we get out of the house, we don't do a very, very good job. Some of that stuff in the bathroom, think of your shampoo bottles, some of your over-counter medicines, maybe vitamins, come in opaque, or colored PET bottles. And usually that's to be able to provide some barrier properties that prevent the deterioration of the active ingredients in those materials, whether it be shampoo and over-the-counter medicine. When those materials do end up into the recycle system, they are a contaminant, right? The recycle system is often optimized around a clear PET bottle. And so colored and opaque PET becomes a challenge. And so for us, the problem we were looking to solve is, well, how do you maintain the benefits of that material, but yet solve the issue? So next slide, please. And so that's where we've partnered with several brands, several folks in our industry structure, and leveraged the recycling partnership and the PET coalition to figure out, okay, how do we pool our resources, be able to provide grants so that material recovery facilities, MRFs, and reclaimers are able to invest and be able to do a better job of capturing these materials once they get into the system, creating essentially a bale then that can go to folks like us and can be easily recycled, where today those materials would drop out as a contaminant and then end up, most likely landfilled or downgraded at best. And it has several advantages. I mean, number one, it's allowing municipalities to get more materials into the bin, right? Accepting colored and opaque PET, accepting thermoforms, so more stuff that can be recycled. Two, when it gets to those recovery facilities, we're able to remove them out so they're no longer a contaminant. That's a better quality bottle bale to be returned to a new bottle via mechanical recycling, and then you've created a feedstock for us. And then part of that is ultimately, or also is some education, being able to make sure people recognize that, hey, we need to do a better job in the bathroom. There's some materials in the kitchen that can go in the bin. Net result is, between this initiative, we're looking over the next couple of years to basically increase the recycling of hard to recycle PET by 250 million pounds versus what it is today. Again, doesn't solve the problem alone, but very significant step forward and a great example of a variety of industry partners coming together to solve a problem. Next slide. As I mentioned, when we get outside the home, we're not as good recyclers. Sporting events are a great venue, gathering lots of people. You generate a lot of waste materials. And so we have been partners for a long time with the University of Tennessee's Good Sports program. And a couple years, we decided to take on a challenge to say, hey, let's see if we could set a world record for the most recyclables collected at a sporting event. And so in 2022, we did that. At an event in Knoxville. Last year, we decided to up the ante and issued a challenge to the University of Michigan and some of our value chain partners, and we did a recycle bowl. We maintained our record and broke our record. Net result, though, was through that sort of sporting event, we got more collected from those venues for recycling versus it going into the trash. And then we had an opportunity to create awareness and education amongst 200,000 some spectators. So a great way with a little bit of work to try to do something positive, accomplish those two objectives. Next slide. So we will be one of the largest facilities in the recycling facilities in the country when we get lined out here in the coming weeks. Unfortunately, the city of Kingsport, where we're headquartered, is one of many municipalities across the country that has discontinued their curbside recycling program because it was not, in short, they were losing money doing it. And so, we thought, well, okay, what can we do to help create access and bring recycling back into the region? And so an example of, we partnered with Food City, a local grocery store chain in the tri-state area. And programs started behind the store of collecting recyclables from the employee break rooms. We've done similar things on our own campus of setting up recycling for it. And now we're beginning to put the first bins are going in place at food stores throughout the region, such that we have access now for folks in the community. It failed because it's oftentimes really inefficient for Waste Management, Republic Services trucks to be driving up the hills of Appalachia. But those people absolutely do come out of the hills to buy their milk, groceries, etc., and provide them an easy, convenient, accessible point to drop off recyclables, we hope will be a good way to continue and increase recycling in the region. So again, another cool example of partnership of another company like-minded that wants to create some good. Next slide. So the last two examples are where I'd say we're really challenging the system in terms of what can be recycled. So more than 3 billion pounds of carpet goes to a landfill every year. We've been partnering with a company called Circular Polymers from California. California is an EPR state where basically there's some funding provided when you buy carpet to be able to enable the recycling of it. So Circular Polymers gets residential commercial carpet in California. They're able to process it to remove the nylon from the polypropylene, from the PET, and they create for us a fiber, a polyester-rich fiber, that we in turn can process through our carbon renewal or polyester renewal technologies, and then be able to take that old fiber and make new polymer, such as the cellulose diacetate that goes into eyeglass frames, fiber that goes into apparel, and other materials. So a great example of how these technologies are leveraged to create new streams. Next slide. Another example is a partnership we have with the USAM, Padnos, and Yangfang on auto. There's 27 some million vehicles reach the end of their life every year. Automotive is a huge materials market and a huge market for plastics, 37 million or 36 million metric tons. When those cars reach the end of their life, they're generally disassembled, shredded to recover the metal. Might be some plastics that get segregated out, but by and large, the value of an old car is in the metal. But you end up then with this stream of a mixed plastic, some glass, some metal. So it is the worst of the worst to imagine recycling. Next slide. So in partnership with the U.S. Automotive Materials Partnership, GM, Ford, Stellantis, we undertook a project a couple years ago to demonstrate that we could leverage our carbon renewal technology to recycle that ASR. And so working with a partner, Padnos, who is doing the shredding, is doing that first phase of recycling, we were able to get that ASR into a form and of a quality that we could feed it into our carbon renewal technology. We could take that and be able to then use it to create a polymer, Triton again, to be able to then make a part that would in turn go back in the car, essentially creating circularity through that. And so this is a partnership where a lot of collaboration, a lot of adaptability and innovation is demonstrating how a material that no one in their wildest dreams could have imagined being recycled, actually we were able to do some of that stuff. Now, for clarity, right, it took a lot of work to get that ASR, and we were fortunate to have great partners. But another example of how these technologies are able to expand the types of materials that could be recycled. Next slide. So again, hopefully this is giving you some ideas, triggered some and sparked some ideas for things that you all might be able to do differently to drive, improved recycling, better diversion of waste, think differently about how to collaborate as you work towards your waste reduction and circularity goals. Again, Bruce, Marta, thank you for the opportunity, and glad to take some questions.
Great. Well, thank you very much, Chris. This was an enlightening presentation. I don't know if you want to say anything about the QR code, but I guess there's another resource that you offer there.
Yeah, so in the spirit of transparency, like we said, we have our LCA information published via the website. We have, this one in particular is talking more about the complementariness. So I encourage folks to look at the QR code, visit our website if you want to learn more about it. We do try to put as much information as we can there to, again, in the spirit of transparency.
Okay, terrific. We have gotten a few questions on Slido. Before we get to them, I'm going to use my moderator's prerogative because there is one important question that I have for you. The construction and development of this methanolysis plant, do you know how it impacted job creation within the region in East Tennessee? Did you have to bring on new people, or is there promotion potential for existing Eastman employees? Or?
Yeah, absolutely. So over the past 3 years, we have, significantly grown, right? That's part of the investment. These technologies, for us, have the potential to transform our company, right? It gives us that next level of growth. So, commercial jobs, sales, marketing, product management, supply chain, we have all grown that. Manufacturing, obviously, engineering. So yes, it has been a good number. I don't know the number off the top of my head, but it has been a significant number of new folks over the past two years, and we would expect the same thing for a second investment in the U.S. and the plant in France.
Okay, terrific, very good. Let me get into some of these questions here. Somebody asked here, who has been providing you with the hard to recycle plastics that can't be mechanically recycled? For example, are you getting it from a municipality or from plastic end use companies?
Some combination of both. So the simplest way to think of where do we get those materials, we're going into the existing recycling waste management value chain, and we're buying their waste. So we're buying off of recyclers. We're working with MRFs to be able to get material directly from them that doesn't otherwise have a home. The examples of like automotive, carpet are better examples of where we're having to sort of create new value chains. We do some smaller programs on eyewear, cosmetics jars, where we're basically creating new take back mechanisms. So it's some combination of the two.
Great, thank you. Another one right here is, are there cost rebates to the entities providing the recycling inputs for this process?
Obviously can't talk about the details of our commercial arrangements, but yes, right? Like, so if we are setting up programs where our customers are providing us feedstock, yeah, we're always sort of negotiating on what the value of that is as a, somewhere they're getting the value of providing us that feedstock.
Okay, terrific. The next one here is, can you talk about the energy intensity of these processes and any opportunities or challenges, particularly using, I guess, renewable energy for the methanolysis plant?
Yeah, so I don't have a pure like energy intensity number. I shared earlier some of the greenhouse gas emissions reductions that we achieve with it, sort of related. In terms of greening up, the processes. So in addition to a goal around circularity to recycle, 500 million pounds of plastic by 2030, we also have climate goals. So we're working towards reducing our scope 1 and 2 emissions by a third by 2030, and then carbon neutrality by 2050. As we think through those plans of how we achieve those goals, we are looking at how we leverage renewables, et cetera, into those things to reduce the energy intensity as well. And as we looked at particularly a second US plant, the France plant, it allows us to be able to do that in the design for the Kingsport facility here that's been here for the better part of 100 years. That's retrofitting is always more difficult than designing it in the front, but absolutely renewables are part of the plan as we think about those climate goals.
And then let me ask a little side question that this question prompted me about. Do you recover any waste heat for this plant, or does this plant provide some waste heat for other processes?
So we do. The processes in themselves, and I'll speak specifically around the methanolysis because that's the one we've been spending most of our time and effort on, Bruce. So that process is pretty high yield. And when I say high, think 90% plus or minus 1% or 2%, depending on the feedstock, meaning that 95% of the PET that feeds into that methanolysis unit, or 90% of what goes in is coming out as usable monomer. That remaining 10%, there's some amount of solid waste that would have to be landfilled. We lose some to wastewater. But I believe there's about 5% of material that has high BTU value that can be used for energy to help feed the plant energy sources as needed. Obviously, we don't count that as recycled content going out, but short answer to your question is yes. Okay. Any waste streams that have energy value, we are using to essentially heat or energize the process.
Terrific. And then somebody here asked how they could reach a place where McDonald's, other fast food companies can use the reusable material in the U.S. I'm not sure if that's widespread yet, but
if you want to do it, you probably need to go to France or Germany right now. That has not started, but we are exploring, that as a key market and trying to develop some partnerships. Those are just very early here. In Europe, you have the benefit of there's a regulatory policy infrastructure that is driving some of these changes, incentivizing some of them. So I don't think anyone would be surprised. The recycling infrastructure, the reusable, refillable infrastructure in Europe is ahead of where we're at in the US.
Okay. And then on a side note, I'll just mention that Wendy's is a Better Buildings partner. So I don't know if you had any talks with them, but they might be, forward thinking enough to want to participate in this. The next one, can we talk directly to you about on a plastic material to having difficulty finding recycling for? Your contact information is in the slides, but if you want some additional information.
Absolutely. As you can imagine, over the past 3 years, we've had many folks, reach out to us. I mean, Bruce, that's how you and I first met, right? Of another, I guess, network member asking about it. So yeah, glad to entertain. Always looking for partners.
Excellent. And then how do you incentivize people to bring their recycling to a drop-off point and not put in the landfill? So I guess this kind of depends on the haulers, the Republic Services and so forth.
Yeah, this is part of the challenge of, how can you educate people on and make it more clear what is recyclable, what is not? How do you make it convenient for them to be able to handle their recyclables? In a rural area like us, part of the challenge is if, the county sets up just a handful of convenience centers, that's not really convenient. People generally may not go out of their way to do it. That's part of the reason why we're trying to partner with Food City, because people are going to go to the grocery store, and if there's a convenient drop-off location there, might that increase participation? Yeah, this is one that certainly Eastman is not going to solve on its own, but that idea of trying to make it convenient, trying to educate folks so they know what can be recycled, because all the consumer research that we've done indicates people want to do the right thing, right? They want to recycle. There's a gap between intent in action. And so how can you create things and make it easier for people to do that? That's part of what we're doing ourselves, as well as through the PET Coalition and the Recycling Partnership.
Okay, then it makes me wonder if there might be in the future opportunities to work with the Safeways and other, kind of food distribution companies.
Yep.
Someone's interested in life cycle data and wonders, does recycling this way save greenhouse gases or increase them as compared to landfilling?
So let me answer this way. So we compare versus the virgin intermediate or virgin polymer we produce. And so we measure our reduction there. Today, we use what we refer to as sort of the cutoff method. So we're not taking credit for like the avoided emissions. We're not taking credit or penalty for the end of life. We essentially start at zero where the waste is generated, and then we're capturing there. That is something that we continue to look at, but today we sort of cut off the waste streams, start with essentially zero burden.
Okay, excellent. And then there's another one that's similar, so I'm going to skip that one. And it looks as though a couple of people have asked about commercial real estate, construction industry, building operation for improving recycling. Feel free to jump in and tackle it.
Beyond carpet, we probably have not had or tapped into or explored that market for materials. And I think it's by virtue of when we look at polyester rich materials, packaging is a big one, fiber is a big one, like textiles, right? Those are the places that we've started because those are the largest markets for polyester materials. And so trying to work through those first and foremost has been our focus. But we know carpet is an example, draperies, home furnishings, they have a lot of polyester in there. That's just not a space though that we have started, but it's a valid opportunity for sure.
Okay, terrific. Well, I think that takes care of the major questions that we've gotten so far in Slido. One quick note, and perhaps also a question for you. You mentioned that PET is one of the feedstocks that are easy or good for this process to recycle. Yep. The production of PET, or what we call polyethylene terephthalate, is actually very intensive, energy intensive. It requires blow molding, compressed air blow molding, and it's very widespread. Almost all soft drinks, water bottles, and so forth are PET bottles. If we get to a point where you start recycling large volumes of PET, you could obviate the need to generate the same volume year after year. And therefore, there could be an energy benefit to this recycling. So that's another thing to keep in mind right there.
Yeah, absolutely. And again, those are things as we kind of move on the next phase of our life cycle program of beginning to understand, can we really quantify the benefit of creating circularity? To your point, right? We could get to the point where the amount of virgin plastic needed into that, true virgin plastic, goes down significantly, right? Because you have mechanical stream that's working, the waste from that and other streams are being leveraged through molecular recycling to return it. And so your need for true virgin could go down significantly. And with it, then you would expect the energy intensity of greenhouse gas emissions.
Okay, terrific. Well, thanks again. I think that takes care of our Q&A session. If you'll go to the next slide, please. I think we want to make a plug for the summit. Yes. So just a quick reminder for those of you who are still on the phone, April 2nd to 4th, Washington, D.C. Come on down, get recognized, attend sessions. We're going to have one of our more interactive sessions for the industrial program again there, the Choose Your Own Solution. There's also going to be a lot of good building and plant tours. So we look forward to seeing you all there. I think next slide, please. Yeah, so this is our webinar series the rest of this year. So feel free to peruse the website and sign up for the ones that are of interest. I think they're all going to be pretty good. So I'm a little biased in that sense, but feel free to check out our website. And I believe that's our last slide. I'd like to thank everyone for joining us today, and hopefully y'all find it very enlightening. And we'll look forward to seeing y'all again.